Hey there, algebra kids. Welcome to your very first video. And I'm going to cross this out. That should say video 1.1. So you can start your notes for the summarizing part of whisking for video 1.1, solving two-step equations. Remember, whisking stands for watch, summarize, and question. So you're going to watch the video. While you're watching, you're summarizing with notes in your notebook, and then we'll test what you learned afterwards with a hot question. So your first video is about solving two-step equations. Some definitions you need to get down. It's not necessarily definition, but your steps. This will be either the page where you write down vocabulary or processes. Today it's going to have steps. So the steps for solving two-step equations. One is combine like terms on each side of the equation. Move any constants using the opposite operation. Remember, we always move things from one side to the other using the opposite operation. Think about in Dragon Box when we flipped the card across the equation sign, the split screen, it would flip from positive to negative or night or day. We always have to move using the opposite operation, whatever is going to cancel that term out on the other side. And then you move the coefficient after you've moved any constants, doing the same thing with either usually multiplication or division depending on the operation that's being performed. And then check your work. Always check your work. So get those 4 steps down. And we come to our first example. What is the solution of 2x plus 3 equals 15? So what I'm going to do is go back to my steps. And I see that there are no like terms on either side of the equation that I can combine. So the first thing I'm going to do is move my constant. And the constant, remember, is just the number with no variable. So that is positive 3. So what I'm going to do to move positive 3 is subtract 3 from both sides because I want that to be 0. I want it to be gone. And 3 minus 3 is 0. And I have to do it to the other side to keep it a balanced equation. So 2x equals 15 minus 3 is 12. Okay, now I'm at step 3 where I move any coefficients. And I see my coefficient is 2 right here. The number in front of the variable being multiplied by it. And since this is multiplication going on here, I know that I have to do the opposite operation, which is divide. So I'm going to divide by 2 on both sides. 2 divided by 2 is 1. I want 1x. X equals 6. But I'm not done yet because I have to do my check. So I'll do my check over here, and checking, we just substitute back in our value that we got. So I'm going to substitute 6 for x and see if it's a true equation. If it's a true equation, once I evaluate this, we did it correctly. And yep, 15 plus 15 equals 15. True equation. Good job. Okay, so probably the most important skill that you can do with equations is to build your own from word problems. So this example says you're making a bulletin board to advertise community service opportunities in your town. You plan to use a half sheet of paper for each ad. You need 5 sheets of construction paper for a title banner. You have 18 sheets of construction paper. How many ads can you make? So what we need to know is the last question. How many ads can we make? So I'm going to assign my variable to that question and say A equals the number of ads we can make. We also know that you have 18 sheets of construction paper. You need 5 sheets of construction paper for a title banner, and you plan to use a half sheet of construction paper for each ad. So the total sheets of construction paper that we have are 18. So everything is going to equal 18. Well, how many ads do we have now? Well, we have half a sheet for each ad, and then we need 5 of those sheets to go into the title banner. So those are set off to the side. We can't use those 5. So now we have our equation that we built. and we can solve. So I'm just going to take away 5 from each side, move my constant. I have 1/2 a equals 13. And now I have 1/2 of a. That's also saying like a over 2, a division problem. So to get rid of fractions, we either multiply by the reciprocal, if you remember that term, or just 2 over 1 to cancel out those 2's that are in the numerator and denominator now. So if I multiply by 2 over 1 on this side, I have to multiply by 2 over 1 on this side. So a is going to equal 26. We can make 26 adds with 18 sheets of paper. Now here we have another type of two-step equation where we have 2 terms in the numerator and a denominator, and we need to find out what the value of the variable in the numerator is. So the first step in these type of equations is to get rid of the denominator. And like I said before in the previous example, the reciprocal is the opposite of a fraction. So if I have 1/3 as my fraction, that's technically what this is here. This is x minus 7 being multiplied by 1/3, but we don't need to put the 1 up in the numerator because of the Ninja one. So you just see the 3 in the denominator. So in order to cancel out fractions, you have to multiply by the reciprocal. So I'd multiply by 3 over 1. And that equals 3 over 3, which is, as we know, is just 1. So that's why we multiply by the reciprocal. So I'm going to multiply both of these sides by 3 over 1. So by doing this, I cancel out the 3's. I'm left with x minus 7 equals negative 12 times 3 is negative 36. Then I'm going to add 7 to both sides, so now I just have a regular one-step equation, and I get x equals negative 29. So for your hot question, you're going to follow the link under the video and post in the Google Doc your answers to the hot question. So I need you to take what we just did in the previous slide and try to solve for x in this equation. Remember, to get rid of a denominator, you multiply by that reciprocal. So go ahead and try, and we'll talk about it tomorrow.